Hello, welcome to Arbind Singh Academy. Before break, we had discussed some question and this video lecture number 4. In previous lecture, we had discussed some questions and we are going to continue the same. Some questions are still left, so we will discuss first all of them, and thereafter we will solve some more characteristics of complex number and representation of complex number as well. But before doing this, I would like to discuss some characteristics of complex number, and these are related to polar representation of complex number. So the first thing, that the question which was I left, third question was given, and the question is given like it is discussed that convert each of the following complex number in polar form. Convert each of the following complex number in polar form. Right? So question number 3 is there, and this is 1 minus iota. So 1 minus iota can be written as r cos theta. Question is this. Let me write the solution in the next line. So let you write 1 minus I is equal to r cos theta plus iota sin theta. This is in polar form, right? Steps, what we have mentioned in earlier, you can do that, but here r is equal to under root a square plus b square usually in this formula, and what will be happen? 1 square plus minus 1 whole square, and what is that? That is under root 2, and theta is equal to given by, so tan theta is given by minus 1 b by a, and what is that? Tan theta is given by b by a, that is minus 1 upon 1. And since theta lies in fourth quadrant, 1 minus iota lies in fourth quadrant, and therefore fourth quadrant, and therefore theta is equal to minus of, this is modulus of this is taken as 1, and 1 is pi by 4, but theta is minus pi by 4. So from first, one can write here in polar form. We can write it 1 minus iota is equal to r, that is root 2, cos minus pi by 4 plus iota sin minus pi by 4, and which will come up like root 2 cos pi by 4, because cos minus theta is cos theta, and sin minus theta is minus sin theta, so sin pi by 4, and this is it, polar representation. You got it. I hope you know that cos minus theta is cos theta, and sin minus theta is minus sin theta. So this is what I have used here. Okay. The next question here is minus 1 plus iota. Fourth question is given here, minus 1 plus iota. So again here you can write it, let minus 1 plus iota is equal to r cos theta plus iota sin theta, isn't it? And that's equation 1, where r is equal to, as per previous question, under root a square plus b square, that will be again under root minus 1 square plus 1 square, and that is under root 2, and theta is given by tan theta is equal to b by a, that is here tan theta is equal to 1 upon minus 1, but z lies in which quadrant? Second quadrant. But z lies in second quadrant, but minus 1 plus iota lies in second quadrant, and therefore theta is pi minus what will come? That will be absolute value is 1 and 1 is pi by 4. So pi minus pi by 4, that is 3 by 4. So from first we can write here minus 1 plus iota is equal to root 2 cos 3 pi by 4 plus iota sin 3 pi by 4, and that will be the answer of this question. So this is the answer. I hope you got it. Now question number 6 is there, and question number 6 is written like minus 3 only, minus 3, and you have to represent in polar form. So minus 3 can be written as r cos theta plus iota sin theta, and minus 3, better to write minus 3 as minus 3 plus 0 iota, minus 3 plus 0 iota, r sin theta. We can write like this, 1 where r is equal to under root a square plus b square, isn't it? So that is why minus 3 square plus 0 square, which is 3, and tan theta is given by argument, that is b by a. So 0 upon minus 3, but 0 upon minus 3, it lies in which quadrant? But minus 3 lies in second quadrant, right? Real axis of negative side. So right, but minus 3 plus 0 iota lies in negative side of real axis, and therefore theta is equal to pi. Theta is pi, and hence from first we can write here, and therefore from first we can write minus 3 is equal to 3 cos pi plus iota sin pi. I hope you got it. This is the answer. Now the last question is 7th, is root 3. 7th question is root 3. So again we will write here root 3 plus 0 iota, that is r cos theta plus iota sin theta, isn't it? And that will be equation 1. So we will write here r is equal to, where r is equal to under root of a square plus b square, that will be under root 3 whole square plus 0 square, and that will be root 3 again, because it will be 3, but a square root of 3 is root 3. And tan theta is given by b by a, that is 0 upon root 3, but since root 3 is positive, it lies positive side of real axis, and therefore theta is equal to 0. Since root 3 plus 0 iota lies positive side of real axis, positive side of real axis, isn't it? So like this. So therefore root 3 can be written as from first root 3 can be written as what? Can be written as root 3 times of cos 0 plus iota sin 0. I hope you got it. This is the answer. Now one more question was there, and that is question number 8, and this is written as iota. So we'll write here, let iota is nothing else but 0 plus iota is equal to r cos theta plus iota sin theta. In this way, this is equation 1, where r is equal to under root 0 square plus 1 square, that is 1, and tan theta is equal to b by a, that is 1 upon 0, and 1 upon 0 is infinity. But iota lies positive side on imaginary axis, so theta must be 90 degree, and therefore theta is equal to 90 degree. 90 degree is nothing else but pi by 2. So we will write it pi by 2, and therefore from first iota is equal to, we can write 1, no need to write 1, cos pi by 2 plus iota sin pi by 2, right? cos pi by 2 plus iota sin pi by 2. So that will come. I hope so. You will got it. So cos pi by 2 plus iota sin by 2 is this will be the answer of this question. So these are some properties of conjugate of complex number I have written here. Actually mic was off, but I have written this. So just note down. This is what the property of complex number. If Z1 Z2 be any complex number, then Z1 plus Z2 conjugate is equal to Z1 conjugate plus Z2 conjugate. Z1 minus Z2 conjugate is equal to Z1 conjugate minus Z2 conjugate, and Z1 Z2 whole conjugate is equal to Z1 conjugate multiplied by Z2 conjugate. Similarly, for division, this will be take place, and Z conjugate whole conjugate will be Z, and you have done this, that modulus of Z conjugate and Z into Z conjugate is equal to A square plus B square, where Z is equal to A plus B, where Z is equal to A plus iota B. So that all the properties what we have in terms of conjugate of complex number. Similarly, there are some properties in modulus, but we will discuss later on whenever it is required. Okay. So moving ahead, there is another exercise which I would like to discuss here. That is exercise 5.3. Exercise 5.3. And in this one, there is some question. Solve each of the following equation. Solve each of the following equation. Equations. Okay. So solve each of the following equations. Following equations. And there are some questions, and question is like, first question is given here, x square plus 3, very simple question, is equal to 0. This employee x square can be written as minus 3, and hence x is equal to under root of minus 3 plus minus, that can be written as plus minus 3 iota, right? X square is equal to plus minus under root minus 3, and that will be plus minus 3 iota. That will be the answer. So there are two roots, and earlier we left such questions when a square root comes in terms of negative. In that way, that case we will left and say that there is no real root. Yes, still the fact is that there is no real root, but there is an imaginary roots. So we will write imaginary roots as well. Now the second question is 2x square plus x plus 1 is equal to 0. Again, this can be written as x is equal to 2x square positive, x is equal to minus e plus minus root under b square minus 4ac. What you have learned in class 10th, 4ac, that is 8 divided by 2a, 2 into 2, 4. So this is minus 1 plus minus root minus 7 divided by 4. So we can write it minus 1 plus minus root 7 iota and divided by 4. So I hope you know this. This is quadratic formula, and there is no problem in using this. So I am writing here question number 3, question number 2, and that was question number 1. So question number 3 is x square plus 3x plus 9 is equal to 0. In that way also you will use quadratic formula, minus 3 plus minus root under b square, that is 3 square minus 4ac. A is 1, c is 9 divided by 2a. So we will write it minus 3 plus minus 3 minus 4, 9 4 ja 36. So under root minus 33 upon 2, and moreover we will write it comfortably as minus 3 plus minus under root 33 iota divided by 2. So there are two roots. Value of x is minus 3 plus root 3 iota by 2, and minus 3 minus under root 33 iota by 2. So hopefully you got it. Now the next question I am looking for question number 4, and 4 is minus x square plus x minus 2 is equal to 0. In that way also this can be written as further x square minus x plus 2 is equal to 0. But still, if I am using for quadratic formula, this is 1 plus minus b minus of minus 1, that would be plus 1, and b square minus 4ac divided by 2a, 2 into 1, and what is that? 1 plus minus 1 minus 8, that is under root minus 7 by 2, and that further comes as 1 plus minus root 7 iota by 2. So the value of x is 1 plus root 7 iota by 2, 1 by 2 plus root 7 by 2, and x is equal to minus 1 by 2 minus root 7 by 2 iota, 1 by 2, not minus 1 by 2, right? So these are the two roots. Similarly, you can write in the previous question also separately, but that is a basic things which I think everybody knows this, and so I am not writing all those things. Now question number 5 is there, and 5 is x square plus 3x plus 5 is equal to 0. That is also given, so we will write it like x is equal to minus 3 plus minus root under b square minus 4ac a into 5 upon 2a, 2 into 1. This is the quadratic formula. I hope you know this, and this is 9 minus 20. So under root minus 11 by 2, and now value of x can come up like, so therefore x is equal to minus 3 plus minus under 11 iota, under root 11 iota divided by 2. So therefore x can have two values. One is 3 by 2, minus 3 by 2 plus root 11 by 2 iota, and another is minus 3 by 2 minus under root 11 iota by 2. So these are the two values of x which may come up. Now there is another question, that is question number 6. I am looking for question number 6. 6 is x square minus x plus 2 is equal to 0. Again the same thing, comparing with, I am not writing all these steps, with ax square plus bx plus c is equal to 0. You can write a is 1, b is minus 1, c is 2, and therefore quadratic formula is like this. Quadratic formula I am just writing here just for recall. Formula is like x is equal to minus b plus minus root under b square minus 4ac whole divided by 2a. This is what the quadratic formula says, right? And this what I am using here. So I am using this one also, but I hope you know that, right? So not mentioning in each and every question, just writing what the answer is, and let me write. So here a is equal to 1, b is minus 1, what I have been written here. So now we will write x is equal to directly, x is equal to minus b minus of minus 1 plus minus root under b square, that is minus 4 into 1 into 2 upon 2 into 1. So that will come up 1 plus minus 1 minus 8 under root of minus 7 by 2, and so it will be 1 plus minus root under 7 iota by 2, and therefore x is equal to, there are two values, 1 by 2 plus root 7 by 2 iota and 1 minus root under 7 1 by 2 minus root under 7 by 2 iota. These are the two values of x. I hope you are getting all these points, isn't it? Just writing sharp and fast, but I hope that you people are so intelligent enough to understand each and everything. There should not be any problem. Now let me write question number 7. So 7 is under root 2 x square plus x plus under root 2 is equal to 0. So if you compare again with comparing with x square plus bx plus c is equal to 0, you will have a is equal to root 2, b is equal to 1, c is equal to root 2, isn't it? Now x can be calculated as minus b plus minus root under b square minus 4ac upon 2a. So we will write here minus 1 plus minus root under 1 square minus 4 into root 2 into root 2 divided by 2a, 2 into root 2, and that will come minus 1 plus minus 1 minus 8, that is root 7 iota divided by 2 root 2. So that will be the two values of x, and hence x can have two values. One is minus 1 by 2 root 2 plus root 7 by 2 root 2 iota, and another is minus 1 upon 2 root 2 minus root 7 upon 2 root 2 iota. That will be the two answers of x. Now question number 8. I am looking for question number 8, and 8 question is given like root 3x square minus root 2x plus 3 root 3 is equal to 0. So we will write it like a is this. Now comparing with x square, if you are comparing with x square plus bx plus c is equal to 0, you will get a is equal to root 3, b is equal to minus root 2, and c is equal to 3 root 3. So better to write d here. Sorry, no d but direct x. X is there. What will be x? Here, let me write x. X is equal to minus of minus root 2 minus b plus minus root under b square, that is minus root 2 whole square minus 4 ac. A is root 3 and c is 3 root 3 divided by 2a, 2 into root 3. So that will come up like root 2 minus minus plus, plus minus, this is 2, and 4 3 ja 12, 12 3 ja 36. So 4 minus 36 is minus under root 32, and minus under root 32 can be written as 4 root 2 iota divided by 2 root 3. Now the things will come like, we can write it like value of x are root 2 upon 2 root 3 plus 4 root 2 upon 2 root 3 iota, and another one is root 2 upon root 2 root 3 Simply we can cancel by root 2, isn't it? Let me write cancels by root 2. Then what will happen? If I cancels by root 2 can be taken common, and root 2 that cancels this root 2 by root 2 times root 2 into root 3 is root 6. So value will come like 1 by root 6 plus, and if root 2 has been taken common, so 4 by root 6 iota, and another value will be 1 by root 6 minus 4 by root 6 iota. So these are the two values which can come up by using this. Now the next question is question number 9, and 9 question is given like question number 9 is x square minus plus x plus 1 by root 2 is equal to 0. Again this can be written as root 2x square plus root 2x plus 1 is equal to 0. And so x can be written as minus root 2 plus minus under root 2 का whole square minus 4 into a root 2 into c1 divided by 2 root 2. So it will be better to write minus root 2 plus minus root 2 whole square is 2, and 2 minus 4 root 2. 2 minus 4 root 2. So it will be under root 2 minus 4 root 2 divided by 2 root 2. So if I take 2 common from this, then it will be outside minus root 2 and root 2 will come. 2 take common from inside, then it will be under root, that will be 1 minus 2 root 2 and divided by 2 root 2. So root 2 can be cancels out, and that can be written as minus 1 plus minus under root 2 root 2 minus 1 iota divided by 2, because root 2 will be cancels out. And why I have taken iota? Because negative sign is being taken common out, which will under root of minus 1 is iota. So there are two values of this x are like minus 1 by 2 plus under root 2 root 2 minus 1 iota divided by 2, and another value is minus 1 by 2 minus under root of 2 root 2 minus 1 by 2 iota. So these are the two values of x. And one more question is there, and that is question number 10. That is x square plus x by root 2 plus 1 is equal to 0. So this further can be written as, that is also root 2x square plus x plus root 2, isn't it? Root 2x square plus x plus root 2 is equal to 0. Now again here x can be calculated as minus 1 plus minus b square. B square is minus 1 whole square. B is 1, not minus 1. Right? B is 1 here. So 1 square minus 4 into a is root 2 and c is also root 2, divided by 2 into root 2a. So that will come up like minus 1, this is 1 minus 8, minus 7. So it will be 7 iota divided by 2 root 2, and therefore two values of x will come up like, two values of x are minus 1 upon 2 root 2 plus root 7 upon 2 root 2 iota minus 1 by 2 root 2 minus root 7 upon 2 root 2 iota. So we can write like this. There is no problem at all. And these are all about this exercise. I hope you have enjoyed all these solutions and you have got the idea how to solve these questions. Although these questions are from class 12th level, 10th level, but still, because it is a part of syllabus, so I have discussed this, and hopefully you have enjoyed all those solutions, because these are too easy and you have capability to solve all these questions. So that is why I have made it too fast. I have solved it too fast. But even then, if there is any problem and you are not able to get it appropriately, then please watch this video again. Definitely will be able to get it. I have done it fast, and in next class we will discuss more properties of complex number, and if possible we will discuss some questions of miscellaneous exercise, because there are some important questions and that may come during the examination. So we will discuss in the next class. Till then, I hope you will revise all these things, and if you haven't subscribed this channel yet, please subscribe. Do subscribe this, or you may join in our video classes through app Movisala, and if you download this Movisala from Play Store, and you will enter the code, our institute code, that is 2ARSA. AR means Arbind, and Singh, S for Singh, A for Academy. So ARSA 2020, and then definitely you will be able to see the video and notes. And if you want to find a complete course for 9th, 10th, 11th, 12th, or whatever any classes and JE or NEET, then you have to buy this course. So in which we will provide notes, ebooks, test papers, videos, everything will be there, which will be a complete package of our study material and videos. So see, if you think it is good for you and you want to stay at home and anywhere, anytime you want to study according to your convenience, so you can utilize this opportunity and register for this program. Okay, thank you. God bless.